This paper discusses using of a multi-factor linear regression model to predict bronchial asthma severity. Allergic diseases prevalence in both children and adults increases year by year. Bronchial asthma in children is the most common chronic respiratory pathology. It is known that an early disease manifestation and intensity of clinical symptoms are defined by the combination of genetic and environmental factors. The identification of factors that make asthma more difficult to control will help to eliminate causate or precipitating factors. Regression models are used for preliminary estimation of bronchial asthma severity. To demonstrate the methodology for constructing approximate models of 5-parameter regression, we will use the results of clinical study for the severity of bronchial asthma in children of the Kharkiv region in 2017. The asthma severity analysis group includes 90 children aged 6 to 18 years. The structure of the group was as follows. The main subgroup includes 70 children with bronchial asthma, the control group, 20 healthy children. We analyzed the data of survey of parents about the symptoms in patients, characteristic of bronchial asthma, as well as the history of the disease of the patients. The information served as the basis for values of the qualitative factors used to build the regression model. The clinical features of the cause of the disease have been studied. Based on the results of laboratory studies, the values of the quantitative factors of the model were formed. Taking into account the selection criteria, we take 6 factors from the table to build 6 proposed models. During the analysis, 142 factors were considered. For these factors, the correlation coefficients between the model regressors and the correlation coefficients between the regressor and the observed value are shown in the slide 4. To build a linear regression equation, we introduce some dimensionless parameters corresponding to the dimensionless value of the observed value and the dimensionless values of the model regressors. Then the regression equation can be written in dimensionless form. To calculate the coefficients in the linear regression equations, we will use an approximate formula. The forecast error of the observed value is a value proportional to the square of the correlation coefficient between the model regressors. Poster 7 shows linear regression models for predicting an observed value in dimensionless form. An exact model is given, an approximate model is given, and an estimate of the error as a result of replacing the exact model with an approximate one is presented. Analysis of the research results presented in the table demonstrates satisfactory accuracy of the approximate linear regression model. The error of replacing an exact model with an approximate one corresponds to the expected value of the error. Poster 8 demonstrates a technique for moving from a dimensionless linear regression model to a dimensional linear regression model. Poster 9 shows the linear regression model used in clinical research. An approximate linear regression model was used at the preliminary analysis. In a detailed analysis of the observed value in clinical research, an approximate linear regression model was replaced with an exact model. The proposed technique is based on the fact that when predicting the severity of bronchial asthma, the observed value depends on a large number of weakly related factors. To construct approximate multi-parameter models at the stage of preliminary analysis of the severity of bronchial asthma disease, significant computing resources are not required. The scope of application of approximate models is presented, as well as an estimate of the error when replacing the exact model with an approximate linear regression model. The presence of a strong correlation between the model regressors significantly affects the indicated error. Thank you for the attention.